All right, the synthesis strategy involve an epoxide. Okay, so first step we add this epoxide synthesis. And then if you look at a nucleophile, we go attack one of this carbon, open the ring. So you're gonna end up with two functional groups next to each other. If you see two adjacent functional groups, think about epoxide. Okay, so I'll give you some examples. So if you add a strong nucleophile, we go attack at the list substitute carbon, but you're gonna end up with the two functional groups next to each other, right? We have an alkoxy group and hydroxyl group, cyanide and hydroxyl, sulfide, thiol and hydroxyl, alkyl group and hydroxyl, right? Hydride and hydroxyl. Acid catalyze is gonna go to the more substitute carbon, right? So X go in there, go in there, go in there, but they all have similar feature where, which is two adjacent functional groups. Adjacent mean next to each other. All right, so it's gonna be eyes training a little, but once you can see it, once you can see it, you're gonna see this, like you recognize this. For example, two functional groups next to each other. See that? We have a methoxy group, we have a hydroxyl group. This gonna be come from the this nucleophilic attack right there. All right, so open the ring. All right, how do we make this? To make an epoxide, you need an alkene, right? And if you want to make an alkene, you need a leaving group. And to add a leaving group on a regular alkane, of course we can, radical reaction, right? All right, so right here, so we're gonna add the radical into it. So add a bromine, chlorine, anything works here. No, gonna be bromine. Chlorine gonna go everywhere, right? Bromine gonna go into the middle right there. Really specific to the more substitute carbon. Okay, and then so we're gonna get bromine there. What else? We have to make a double bond. Easy. So this is gonna be elimination, and elimination is the double bond is on more substitute carbon that have more substitute double bond. So this is gonna be side product. So use small base. Sodium hydride, sodium hydroxide, ethoxide, methoxide works. Look like that. Okay, do elimination. This is gonna be major product. Of course, you get the Hoffman product too, but not a lot. So we isolate the major product and move on. Let's say the next step gonna be add the epoxide ring on it, MCTBA, of course, and you get enantiomer. The oxygen can get on the on both sides, on top and the bottom face. Last step. All right, so we need to add a methoxy group right here. Now, watch out though. If you use a sodium methoxide, which is strong nucleophile, it will go attack right there. Right? So this is not what we want. We want the methoxy group attack at the more substitute carbon. So in this case, you have to go in acidic solution. Right? So make this carbon here more positive than the other, and methanol gonna go. So look like that. Methanol gonna go attack right there. Here we go. That's what we got. Okay. All right. One more time. So try to do by yourself first, or just go with me, either one. But if you do by yourself first, let's check with me. This one from the epoxide to a ketone. All right. Let's say from ketone, can you make an epoxide from this? Well, ketone can be made from oxidizing this guy, right? And this guy can be made of can be made from epoxide. Open the ring. That's it, right? All right. So from epoxide, we're gonna go forward now. Epoxide, we have to go open the ring, attack on that side. We need a hydrogen attack on that side. So LAH is the way to go. Hydride attack there, right? Adding an acid here to protonate that the oxide group and kill any leftover LAH in the solution. So we get the alcohol. And the next step going to be easy. Use whatever you want. PCC, dichromate works. Here we go. All right. So if you see two functional groups next to each other, think about epoxide. It helps you out a lot. Okay. All right. Go to the next synthesis strategy.